Hello, thank you for getting tuned for this another video. Today we're going to deal with logarithms. So for us to start with logarithms, we need to go through its laws to understand. Remember, you can't play any game without understanding its rules and laws. Yeah, I think that's why many people get it wrong because they just want to play the game but they don't understand what they're supposed to do or what they shouldn't be doing during the game. And then they get penalized and then they cry afterwards. So, yes, log. How will log help us? Log will help us when we find the inverse of a function. I did inverses uh, sometimes back, but even the law of logs will help us with that. And it's as well important when we are doing financial maths. There's a where like we want to determine the period. Yeah, we're gonna go through all this. Don't worry. I'm here. I'm gonna help, and those who can help as well will help too. Thank you for tuning in. So today, as I said, we're going through the log. So the first law, law number one of logarithms, says the log, let's just say the log of base a. Whenever you see a value down here, just know it's a base, and then in the power of a times b. Whenever it's raised next to the log here, it's called power, and then it's equals to, let's just say, when we are solving for x and there's an x in here, just know this is it's what, it's an exponent. Then use the whole, you see this whole thing can be rewritten or represented as a as the base to the exponent x, which gives you what, the power, our power in this case, it's what, b times a times b, not b times a in this. So let me highlight what I just said. This is the power, this is the base, this is the exponent. Always this is the exponent, this is the base, this is the power. So it's all up to you which other way you want to represent it, especially when you're solving for x or finding the inverse. So yeah, and then another law goes like, when you have log of base a, let's say you have power a, and when you are adding it to another log of the same base, remember, of the same base meaning still base a down here, and then the power is different of b. This can be rewritten as what, a single log with a single base, because the bases are the same, and then you multiply, because it's, you multiply a and b just because there's a plus sign here, right? Sure. Yeah, let's do an example of this. Let's say you have log, you have log 2 and 5 plus log 2 4. All this will happen. This, the whole statement is written by this statement on the left on the law, which can further be simplified to just say log 2, then we have 5 times 4, just because the bases are the same, 2 2, then is the same as saying log what, 2 20. Same, that's all the first law says. That's what the first law says. Let's say then you have log, so you have log 5 2 plus log 2 4. In this case, since the bases are not the same, you cannot, which one will you choose, because they're not the same. So this doesn't hold, this doesn't hold, it's wrong, right? Only when the bases are the same, that's what you do. only when the bases are the same. Great. Then another law, law 2, law 2 tells us, law 2 tells us it's actually the same. It says if your log base b at a and b minus log at the same base a b, what will happen is that you're just going to have one log with base a because the bases are the same, but in brackets you're going to have a divided by b, right? Yes. And it's similar to that. An example would be if you have log 2 20 minus log 2 5. This can be represented as a single log with base 2 because they're both base 2. Then because we are subtracting here, then we're going to say our a is 20 divided by our b, which is 5. Then this will be the same equivalent to log what? Log 2 4. Makes sense now. Why 4? 20 divided by 5, it's 4. Then yes, which as well leads us to the third law of logarithm. The third law says what? If you have a log with base a and here you have a which has an exponent, let's say an exponent n, right? Then all this will happen is that this exponent will now no longer be an exponent but become a base. No, become a coefficient. Then it's going to be n times log base a and then a. It just moved from exponent to the. Remember, this capital letter A is not an exponent to b to this small letter a as a base, right? Don't confuse them. So similarly, an example would be if we have log 2 4. What happens is that this can be written as log what 2, and then 4 can be broken down into 2 to the exponent 2. Then you see this one is an exponent, then it calls us to say 2, it calls us to, this 2 is the same as n, then it becomes a coefficient. Now we have 2 log 2 and then 2. This 2 is this one, this 2 is that one. So you see, that's what log 3 tells us. I hope everybody is happy until this point. I hope everybody is happy until this point. If you have any question, please let me know so that we can do all this together. Then the fourth law, says what? Fourth law says, now that let's say we have log a and then as well here you have a, they're the same, a, always this will be equals to 1. That's what the fourth law says. Always is going to be equals to 1. For instance, here you see here we have 2 log 2 2. All this means is it's just going to be 2 as this coefficient, and in brackets we have 1 because this is the same as that. It's 1. Then our answer here is going to be 2. I hope I'm making sense with fourth law. So another example, let me just make another example. If you have log 3 3, will forever be 1. If you have log 10 10, it will just be what? 1. And always know that log, if it doesn't have a base, that's know there's an invisible term. So meaning log 10, it's forever 1. If they didn't give you a base, that's know that the base is 10. There's an invisible term that's there. Don't forget, because sometimes they might not give you the base. And yeah, that's about it. This it's about it, so that we will use the logs. Let me just do an example to illustrate my point of this. Let's say you have 5 log 2. Remember, the base is 10. It's not given, but it's 10, we know, as I've explained previously. And then we have log 2 log 5. And then they tell you to express this as a single log. See, these are 2 logs. Now they want you to kind of like combine this. With this plus, we can see the first law. But this 5 as a coefficient, you can use the third law as well to take back the n as an exponent, right? So 5 log 2 is in this form. We can take the n back by using the third law. Then we can have log 2 to the exponent 5. The base here, it's not given, but we know it's 10. There's no need for us to write 10 because we didn't write it as well too. Then even this side, we're just gonna have log 5 and then squared. Then as a single log, that's when we can say log. Because it's plus, it takes us to the first law. It's written in this way, we can write it in that way, whereby it's gonna be 2 to the exponent 5 times 5 to the exponent 2. Then a single log, this becomes our 32 times 5 squared, it's 25. I don't know what's that. 32 times 5, 25. My calculator tells me it's 800. Then this is a single log. You can take it from there. If they want you to put it into decimals, you can go and say log 800. Then you get something close to 2.903 and right. Yes. Any question until this point? We can do the last example before we close this. The last example, let's say you have log 4 minus log 10 minus log 4 again. There's so many things to go about doing this. This is a straightforward. It takes back to log 2. It's just that you have an additional, because you can see the bases are all 10, 10, 10, they're all the same, right? All you can do, or you can, there's so many ways to kill this. Or you know that log 10 is equals to 1. I just told you here log 10 is equals to 1, because there's an invisible 10, then it takes you to log 4, making this all of it 1. And this are like terms. This one is positive, this one is negative, so this cancels that. Then you're left with negative log 10, and we know that log 10 is 1, then you're going to have negative 1. That's your answer here. Or you can go through to the second law route by saying the first log 4 we divided by 10, the first two, you add them together using the law, the law number 2 of logarithms. Then minus log what? Minus log 4 again. It still takes you to log 2. Then you're going to be left with log 4 over 10 divide by 4. And then we do all the multiplications, whereby this it's no longer division because it's hard to work with division. Then we have 1 over 4. Then you see this is a numerator, this is a denominator, and the same, then they cancel out. Then you're left with log into 1 over 10, right? There's an exponent. Remember, now you are, let me use a different color. You are left with log what? log 10 to the exponent negative 1, because 1 over 10 is 10 to the exponent negative 1, and there's an invisible 10 here, meaning all you can do from here, you can use law number 3 by taking the exponent in here. Then you're going to be left with negative log what 10 to 10. I'm not supposed to write this 10, I'm just writing it for your argument's sake to show you that then this, the whole log becomes 1, and then it's going to be negative 1. So you see this is negative 1, still here it's negative 1. So thank you so much, see you soon. I hope you can use these logs when necessary, and thank you so much.